Okay. So what we're doing today is we're finding the equation of a parabola. Now, there are going to be one of two equations we're going to look at. It's either going to be in what they call vertex form or intercept form. It's going to be in either vertex form or intercept form. And the main way we'll tell the difference between the two is what is given to us. If it's going to be in vertex form, they're going to give us the vertex and a point. They'll give us the vertex and a point somewhere on the line. If it's x-intercept form or intercept form, they're going to give us the x-intercepts and a point. They're going to give us the x-intercepts and a point. Now, sometimes they'll be given like p equals or q equals, the x-intercepts are these two numbers, or it'll be given as a point. So x1, comma 0, and x of 2, comma 0 as a point. And we know it's an x-intercept because the y value for these points will be 0. The y values for these points will be 0. Any questions on this so far? Now, you might be wondering, why do we need the vertex and a point or the two intercepts and a point? And the reason we need that point is it helps us define the equation. And I'm going to give you an example of this here. Because if we look at this here and we said the vertex was this point here, we'll call it 1, 0. It said the vertex was 1, 0. And it didn't give us anything else. Well, you might be thinking, well, okay, we can make an equation based off that. It could be this one here, yes? Let me get another color. So it could be this one. It could be this one. You could have one like this here, or going this way here. And we could have even one really wide. But all of those have the same vertex, yes? How do we know which one we want? That's where this point comes into play. That is where this point comes into play. Because once they give me a vertex and a point, this point here, what they're saying is this point is true for the equation and the vertex. The line, the graph of this equation will go through both. Have I now restricted on where this graph can go? Well, yeah, because it can't be anywhere down here anymore because it has to go through this point. That's why we have the vertex and a point, or the two x-intercepts and a point, because it restricts the function that we're going to have. It defines the function. Now, the equations of what I have and what you have down are going to differ a little bit. I won't have all the text on that page. But this is just a way to kind of walk us through so you get used to doing what we're going to do for this here. Now, when we look at this here, there are two different types, and we have these here. Now, looking at the first one, we're told what? The vertex is 3, 2, and it passes through the point 13, 8. Now, is this y equals a times x minus h squared plus k, or y equals x minus p times x minus q? Well, what are we given? We're given what? The vertex and a point. So we're using this one here, y equals a times x minus h squared plus k, because we were given a vertex. Because we're given a vertex, we're using the equation with a vertex. We're using what we're given. We're given this here, so that's what we're going to be using. Now, the second part is what equations or what variables are missing from the general equation. We're missing a, h, and k. Now, the x and y are just input-output. We don't worry about x and y. Because if I'm trying to find the general equation or an equation for this line, it will be y in terms of x. X and y will stay there. Bless you. The ones that we need numbers for are a, h, and k. Now, out of these three here, h and k are given to us. are given to us. Because our vertex is what? H comma k, yes? So looking at the vertex, 3 comma 2, the value of h is, and the value of k is, so we can plug those in. Y equals a times x minus 3 squared plus 2. So do we know what the variables are and what they are? So part 3 is pretty much saying h equals 3, k equals 2. So for part 3, we're just saying h equals 3, k equals 2. And for step 4, we'll plug this in. Y equals a times x minus 3 squared plus 2. So what's the only thing we have not got a value for in this equation? A, yes? A is the only thing we don't have a value for, correct? Because vertex doesn't tell me A. This 13 comma 8 does not tell me what A is directly. I can't just say A is 13 or A is 8. It doesn't work that way. But we know it goes through that point, yes? If I plugged 8 into this function here for x, it would give me 13. Because it's saying it's a true point. It's saying that when x is 13, got it backwards, when x is 13, y is 8. It's just a true point because it goes through it. The graph goes through that point. So to find the value of a, what we're going to do is we're going to use that. We're going to use the fact that when y is 8, x is 13. So really what we've done so far is we used the fact that 3, 2 is the vertex, and we plugged it in for h and k. H and k. And we got y equals a times x minus 3 squared plus 2, which left us with a. Now what we do is we plug in the point, 13, 8, 8 for y, 13 for x, and now we're going to solve for a. Now we're going to solve for a. And once we get the value of a, we'll plug it back into the general form. We'll plug it in here, and we'll be done. So let's step this out. Let's work this out. Let's solve for a. I can't do anything with 8 yet. But we can do 13 minus 3. What is 13? It's 10. We can do 10 squared. 10 times 10 would be 100. And we would have 100 a plus 2. What do we need to do next to solve for the value of a? We need to subtract 2 from both sides, so we'll subtract 2 from 8. 8 minus 2 is 6 equals 100a. And then we would divide both sides by 100. And we get a by itself. Now 6 divided by 100 would be 3 over 50. So now I have the value of a, yes? So we'd plug it back in, because what we said originally, our equation was what? Y equals a times x minus 3 squared plus 2. Plug it in. So y equals 3 over 50 times x minus 3 squared plus 2. Believe the intercept's the next one? Now, so the steps that we did to find this was first we figured out which one of the two equations we have. Now, because it gave us the vertex, we used the vertex form. We plugged in the values of h and k because it told us the vertex is h comma k. Then we plugged in the point to solve for the value of a. And once we got the value of a, we plugged it back in. Yes? So, okay, let's look at another one. So looking at this one here, they gave us what? The vertex and a point. Now, since they gave us the vertex, we're using what? Vertex form, which is y equals a times x minus h squared plus k, because it is the vertex. They gave us the vertex to start with. So we are using vertex form. What are the variables that we're using? So a, h, and k. Part 3, we know that h is equal to what? -5, and k is 9, because the vertex is h, comma, k. The vertex is h, comma, k. We can plug those in. We can plug those into the general equation and get y equals, well, we didn't know a, but I know x minus -5 squared plus 9. Because we plug in for h and k. We plug in the values of h and k. And that there's our step 4. Any questions on any of this here so far? Any questions on anything we've done so far? Now, really, we can rewrite this negative minus a negative as what? As plus 5. Now, what do we need to find? We need to find the value of a. A is the only variable we're missing. That's the only value we're missing. So to find it, we're going to plug these two values, the point, -7, comma, -15 into the function. We'll plug -15 in for y, so we have -15. A times our x value is -7 plus 5 squared plus 9. So we plug the point in, -7, comma, -15. We plug it in for x and y respectively. When we plug that point in, we don't plug it in for a, we plug it in for x and y, because we're solving for a. Now the first thing we can simplify is this here. Because I could do -7 plus 5, yes? We can do that. We can plug that into the calculator, and -7 plus 5 is -2. Now we can do that also. We can do -2 squared, which would be +4. So we would have 4a plus 9. Now we need to subtract 9 from both sides because, again, we're wanting to get a by itself, which gives us 4a. -15 minus 9 is the same as exactly as combining them, which would give us -24. Then we divide both sides by 4. And when I divide both sides by 4, we do get a by itself, and -24 divided by 4 is -6. So this is our equation, yes? This is what we started with, and we plugged the value in to find a, and we found that the value of a is what? -6. So we have -6 times x plus 5 squared plus 9. So again, we started off with plugging in h and k, because once we figured out that we're using vertex form, we plugged in h and k and got our general equation here. We got this one. Then we use the point to find the value of a, and once we found the value of a, we plug it back in, and we are done with this here. Questions on this here? Because it tells us what the equation is. Because just because we have the vertex doesn't tell us which equation it is. So like when we looked at the start where we had all the different versions of the equation just with that one given vertex, this a value restricts us on what the equation is. because there's only one equation that will go through that point. One quadratic that will go through that point. Questions on this here? We good with this here? Number 3. So looking at this here, are we still using the vertex form for this here? We're using intercept because we were given what? The x-intercepts are these here. So the x-intercept form is y is equal to a times x minus p times x minus q. Now our p and q are the x-intercepts. So they told us -7 and -3. So the values of p and q are -7 and -3. So we can plug those in. So we get y equals a times x minus -7 times x minus -3. So they would both be positive, yes. Yep. Because sometimes it's easier to visualize if it's written out, each step by step. Now, the way that you put these in, I could have put it as, put the -3 first, and then put the -7. It doesn't matter which order. P and Q are just the x-intercepts. So it's the variable that we're missing from this here. A, yes? So again, just like what we did with the previous ones, we're going to use that point to find the value of A. So we're going to plug the 0.5 in for y. So we have 0.05 is our y equals A times the x value is, so -2 plus 7. -2 plus 3. So when I have the x-intercept form, the -2 gets plugged in for every single x. Now when we had it in vertex form, we only plugged it in once. But here in x-intercept form, or intercept form, we plug it in twice because there are 2 x's. Now we can simplify this. So 0.5 equals A. Well, -2 plus 7 is, and -2 plus 3 is, so we have 5 times 1. We have 5 times 1. Well, I can do 5 times 1 times A, yes? It'll just be, because 5 times 1 is 5, times A gives us 5A. Any questions on how we got to this point here? Now, what do we need to do to get A by itself? So we're going to divide both sides by 5 to get A by itself. Because 5 divided by 5, or 5A divided by 5 will reduce to just A. Now we need to do 0.05 divided by 5. Now you can plug this into a calculator. A calculator will simplify it and it will solve this. And if we type this in, we should get 0.01. 0.01. 0.01 is the value of A. So our starting equation that we had before we solved for the value of A was y equals A times x plus 7 times x plus 3, yes? So what do we need to do? I need to plug it in. Equals 0.01 times x plus 7 times x plus 3. So hopefully you're starting to notice that with all of these here, we start off by plugging in the given information that we have, either the vertex, h and k, or p and q. Once we plug that in, we plug in the point for x and y, solve for the value of A, and then plug it back in. So it's these same steps. It's these same steps over and over again. Any questions on any of this here? Any questions on anything we've done so far? Now it just tells us we have the points negative 16 comma 0 and negative 2 comma 0 and passes through this point. Now, it is the intercept form, yes. Now, the reason we know it's intercept form is because the intercept, the x-intercept, it is the x-intercept when the value of y is 0. So when we have x comma 0, this is telling me it's an x-intercept. It is telling me that this is an x-intercept. It tells me this is an x-intercept. So our value of p and q are these two here. So negative 16 and negative 2 are our p and q. It doesn't matter which one we say is which. They're just p and q. And what we'll do is we'll plug those in. So we get y is equal to a times x minus, here I wrote that p is negative 2, x minus negative 16 is this here. Now we don't normally leave a negative minus a negative. A negative and a negative make a positive. So you have x plus 2 and x plus 16 inside the equation. Any questions on how we got to this point here? Any questions on any of this here? Any questions on how we got to this point here? Now what do we do next? We plug the point in. The y value for this is 72. The x value is negative 18, and we plug negative 18 in twice. Because our point was negative 18 comma 72. Thank you. Thank you. So it should be 2. Yes. So we should have y or 72 equals a times negative 18 plus 2 times negative 18 plus 16. Well, negative 18 plus 2 is negative 16. Negative 18 plus 16 is negative 2. Then what can we do? We can multiply those two together, yes? Well, negative 16 times negative 2. Mm-hmm. Then we divide both sides by 32. As those two would simplify out, leaving us with a by itself. And we could plug that into a calculator and see what we get. As I can see, a 2 comes out, so it'd be 36 over 16. 36 over 16. There's another common factor of 2, so 18 over 8, which would be 9 over 4. Now, a graphing calculator, the TI-30XS, or the TI-84 Plus, either one of those will simplify that down to 9/4. It'll simplify it down to 9/4 for us, so we don't have to do that. $16. So what is our equation? Y equals 4 times x plus 2 times x plus 16. We could make it a mixed number, but that wouldn't make it any easier to solve or simplify. So we leave it as impartial fraction or improper fraction, because this is fine as an improper fraction. It's for a general equation. For an equation form, an improper fraction is more commonly used. We don't normally use kind of that whole number in a fraction. We don't write it as a mixed number. We leave it as an improper fraction. But this is our answer here. This right here. Any questions on any of this here? Any questions on any of these here? We feel good with these here? Yes? Okay.